Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be talking about user-defined rules for gates and pumps, or operational rules. What I have on the screen here is the user's manual page here, operational rules, and this is one of the longest pages in the user's manual, so there's a lot to talk about regarding the manual or user-defined operating controls for gates and pumps. All right, what I have on the screen here is a model that I built just for this lesson. We have a river reach, and then up at the top, we have a pump station that connects to river station 5000. Further down, there's a lateral structure at river station 1600 that has a tailwater connection to storage area 1. And then there's also a storage area 2 over here and an inline structure at river station 750. All right, next I'm going to go up to the edit unsteady flow data. We can define boundary conditions for our inline structure and our lateral structure. The options there are the time series gate openings, elevation control gates. If you're dealing with an inline structure, you also have navigation dams. And then for both of these structures, as long as they have gates, you can add rules. So rules is what we're going to be focusing on in this exercise. I'm going to use lateral structure. I'm going to click on rules. And now this is the dialog box, specifically this one here, that we're going to be working with in this lesson. HEC RAS allows users to define how hydraulic structures, i.e. gates, and pumps are operated during a simulation with boundary conditions called rules. Knowing and understanding how rules work in HEC RAS is one of the most powerful and exciting topics. All right, let me back out just a moment. Oftentimes, the user's manual will mention hydraulic structures, and in my understanding, that is referring to gates, i.e. gates in the lateral structure or an inline structure. And then what I can also do is add a boundary condition for the pump station. So I'm going to add pump. Okay. Now we have pump station boundary conditions right here. And here's the pump station. If I click on that, I also have the ability to define the operation of pumps using rules. This is in addition to the generic rules that we've already been exposed to by clicking on either the on-off elevation rules or advanced control rules. Okay. So I'm going to click on rules here for the lateral structure. You can either double click right here or click on the rules button, and then it brings up this dialog box. First, this dialog box, we have a description at the top. This is optional. If you need to describe the code and the logic behind it, the description box right here is a good place to do so. Or if you're working on a team, and it's probably good to describe what the rules do up at the top here, or using inline comments, or both. All right, next down, we have a table here for gate parameters. So I only have one gate in this lateral structure. In fact, let's go ahead and bring up the lateral structure right now. It's one gate group. So we have one gate group here with 3 gates, and then we have a weir or spillway near the top. If I open up the gate details, here they are. It's 3 gates. They all have a height of 4 feet and a width of 10 feet with an invert of 36 feet. I don't think that's too important though, so let's carry on. Okay, open rate, this is the rate at which the gate can open up, and then after that, close rate, that's the rate at which the gate can close. I'm just going to type in 0.1 feet per minute. If the value is left blank, then that just means that the target gate height will be automatically set at the next time step. If it's set, if a value is actually specified here, then HEC RAS will make sure to operate the gate at the correct speed, which means it may take multiple time steps for that target gate to open up to the correct height. Max opening right here and min opening go together. These are also optional. If you don't assign the value, then it's just going to be the maximum and minimum of the geometry itself, meaning 0 is the minimum and then maximum is the height of the gate. But for whatever reason, if the maximum is less than the height of the gate and the minimum is greater than 0, you'd go ahead and type those numbers in there. I'll just go ahead and explicitly state the default values there for 4 and 0. And then initial opening, this is required. I'm just going to go ahead and say the gate starts closed, which is a height of 0. All right, next below that, we have a summary of variable initializations. And this is a table with fields of user variable, the description, and the initial value, as you can read. And I will return to this table once we actually have values in them. So you can see how the data gets written to this table. But it's not something I can write to directly from this interface. Okay. All right, down below here, we have the rule operations. This is the list of rules which we will define after clicking this button and going into the rule operations editor. So this right here is a summary. It's sometimes called a rule set. And let's jump right in. So I'm going to click this button at the bottom here that says enter/edit rule operations. And then what we have is the operation rules dialog box here. Up on top is the list of rules. So that's kind of our working code, if you will. And then down below here is our individual rule editor. I'll call it that. We have 7 buttons here for specific type of options and lines of code we can add up here. This isn't really code. We're not writing code. We're just clicking buttons. So it's almost like a code for people who can't code, basically. And then over the right, there's some buttons over here. It's cut, copy, paste, delete, enable, and disable. So I will also be using some of these buttons to show you how they work once we get started. All right, so I'll describe these buttons quickly and then we'll go through them slowly with examples. So the quick version is comments. That's just adding an inline comment. It doesn't execute. It's just for a label or a description to help the user understand what the code below it is doing. New variable. This is how you create a new variable and assign a value to it. You can also create new variables by clicking the 3 other buttons here. So not just new variable, but also get sim value, math, and table are all ways to create variables or to update existing variables. So this new variable button is basically the last resort. If you don't need to get it from math, table, or get sim value, you go ahead and click new variable. All right, get sim value. This sets the value equal to a variable in the simulation, such as the flow rate at a specific river station or a time of day, or all sorts of different variables are available. We'll take a look at those in a little bit later. Set operational parameters. This changes the operation of the hydraulic structure. For example, changing the gate height or setting a maximum discharge through a gate. Next over is branch if/else. So this is where you can use control logic with if, else, and or operators. There's no loops, but the if and else is better than nothing. And then math and table. Math performs mathematical operations such as summing flow rates or averaging water surface elevations. So you're basically going to build an expression using math, which can be based on other variables or simulation variables. And then the result of that expression will be assigned to either a new variable or an existing variable. All right, finally, table here. This is where a table lookup operation is performed, and the result of that lookup will be assigned to a new variable or an existing variable. All right. Okay, let's go ahead and dig through these buttons a little bit slower and do some examples. So the first one is comments. So I'm just gonna go ahead and select a spot up here and then click comments. And then when I click comment, it's going to add a comment and I just type in the comment right here. So I'm gonna say this is initialize variables. So that is my comment. And then when I click off, the text is green. There's a bang in the front, an exclamation point, which will just tell the interpreter to skip over that line, I assume. Okay, the next one over is new variable. So if I click new variable, down below here where I'm building the operation, building the rule, I'm going to go ahead and give the variable a name. So I'm just going to call it VSA1 for the volume of storage area 1. That may already be a simulation value, but let me just roll with it here. Then we need to define if it's a real number or a integer. So just think of double or integer, I guess, or float perhaps. Now in the case of volume, it wouldn't be negative, but yeah, real number. I'm going to do that, and I'm going to set the value equal to 0 so that the volume of storage area 1 is initialized to 0. Now over in the right here, I can actually describe what that variable is, and I'm going to do that. Volume of storage area 1. And then if I click on this checkbox right here, then this variable will be listed in the table on the previous screen that we saw for initial variable values. So I'm going to do that. I'm going to click, actually, I think it's automatically saved. So if I click off of it, yeah, the text is blue here and it's green for the comments. And then if you go ahead and click on a specific row, it's going to give you the ability to edit that row. So now I can edit the comment. If I click on the new variable for volume of SA1, now I can go ahead and change those values right there. Okay, so I just updated the description and that looks good. So I'm going to click OK. And then now what we see is the volume storage area 1 right here. The initial value is 0. And then what we have is our two rules. The beginning of our rule set is just below here in the rule operations. Okay, so let's go back and click the button to enter/edit rule operations. While I'm here, I'm going to set another variable for the volume of storage area 2. VSA2 will be the name. It'll be a real number. The value will be 0 for its initial value. And then again, I'll just click on the include variable in summary, and then the description will be this right here, volume of storage area 2, and then click OK. All right. So that's good. It's added to our table up above. And actually, let me change the order here. So this gives me the opportunity to demonstrate some of these tools over to the side. What I can do, I really wish there was an arrow up, arrow down, or a cut, copy, paste, but there is with these buttons. I'm going to select row 1 here, click on cut, and then select row 3, the new row 3 below row 2, and then paste. And boom, just like that, I've got my arguments, my code in order here. If for whatever reason I don't want a line to execute, I can just select it and then click disable. And then when I click off, it's got that green text now with a line through it, which indicates to the modeler that this line will not execute. Okay. To re-enable, go ahead and click that row, enable, and then you can click off and boom, now it's working again. All right, the third button over is get simulated value. So this is a value from the simulation. If I click on this, over to the left box, we assign the result to a variable. Either it's a new variable or an existing variable. If I click existing variable, then I have a drop down here to select the existing variables that have already been defined, which you can see is VSA1 or VSA2. All right. But I want to go ahead and create a new variable now. So when I click that radio button, I'm going to go ahead and type in the name of the variable I want to create and define. I'm going to call it Q5000. So this is going to be the flow rate at River Station 5000. Maybe I should just call it RA 5000. And then over to the right here, we have the simulation variables. And as you can see, they're sort of grouped up. So all the time related variables are right here. I can go ahead and click a time or a variable like the month, for instance. This is not the one I want to select, but I'm selecting it just to kind of show you what it looks like. Time, month, beginning of time step. And then also if I just hover over these value over each of the different variables, down here in the bottom left corner of this dialog box, it gives a description of what that particular variable is. Right here it says month of the year, example, August equals 8th. So you know January is 1, December is 12. The next one down is day of year. So January 1st is 1, February 1st is 32, and so on. And then December 31st is 365 or 366, I assume. So you can go ahead and both click and hover to get a different idea of what that variable actually does. If I collapse the time group of variables, but then open up, say, the cross-section group of variables, now we have variables associated with the cross-section. And this is actually where I want to be because this variable here is going to be the flow at River Station 5000. So I'm going to click on flow. And then what I need to do over here to the right is specify the river, the reach, and the river station. And that's exactly what I want, the value that already came up. Okay, so you can see up here the arguments that it's passing in to is river A, reach 1, and then 5000 is the river station. And then this last argument here is the value at the current time step. And that's controlled over here. So if I wanted it to be at the previous time step, then that updates over here. These are the different options, the value of a specified lag. So what that means is if I wanted to set it to the value at that river station an hour ago, 2 hours ago, 3 hours ago, and so on, I can do it that way. And then what other options I have here is average over previous time period, max or min over previous time period. Pretty self-explanatory. But I'm going to just go ahead and use the default, which is the value at the current time step. All right, what I also forgot to mention is that this font size can be increased. So if you come up here and increase the font size, it's easier to read. Let's back it back to, how about size 11 right there? And then also I can click this bold if I want the font to be bold. Okay, I'm going to do one more example here. So for instance, if I wanted to create a variable called G opening, i.e. the gate opening, Then what I could do is click on lateral structure and then scroll down to gate opening right here. And then I have my option for which gate it's referring to, the river, the reach, the lateral structure at River Station 1600, and then the gate group, which is gate group 1. I only have one gate group, one lateral structure, one reach, and one river. So this is a little bit trivial, but you can imagine if you had a larger model with lots of different gates and river stations and lateral structures and so on, that you would obviously need to select this. So here are my 4 variables so far. We've initialized variables. Now it's time to actually do something with those variables. So I'm going to add another comment, but instead of adding a comment, I'm just going to copy this one to demonstrate the copy, and then select down here the target I want to paste to and click paste. And instead of initialize variables, I'm going to go ahead and say something like update gate heights. I don't know. The user manual also mentions that if you happen to rename a variable at any place of the code, it needs to be manually updated everywhere else as well. There's no reference or automatic updating of variable names, so be careful about that. The set operational plan button right here allows the modeler to instruct HEC RAS to make changes to the hydraulic operations, such as changing the gate height. Changes can only be made to the structure that the rule is assigned to. So for instance, what we have here is structure and then a number of different parameters associated with the lateral structure, such as a weir, gate, gate group, gate coefficient, and then at the top, it's structure-wide parameters. I point that out now because, for instance, I'm not going to set this. I'm going to come back to it. I'll say OK, and then I'm going to say OK here. OK, file, save to make sure I don't lose anything. Because if I come down here to the pump station and then I select rules, and then this is a whole new interface just for the pump station. What we were looking at before was this lateral structure and the gate within the lateral structure. But for the pump station, let me go ahead and click enter/edit rule operations. And if I select set operational parameters, now we have a few different parameters here, such as water surface on, off. We didn't have that with the gates, right? Pump flow min and max. We didn't have that with the gate. Pump station wide parameters. Didn't have that with the gates either. So anyway, I just wanted to point that out, that the variable that you assign for this set operational parameter is specific to either the pump station or the lateral structure or the inline structure. Okay, so let me go back to the lateral structure and then let me click on edit/enter rules. Okay, so let me go ahead and click on structure/total flow. This is not the one I want to start with as an example. I'm going to scroll down to gate flow fixed. Here it is, gate flow fixed right here. This sets the gate flow value. Once this is selected, we need to also select the gate group. Now I only have one gate group, so that's it. And I also need to select the value. So I'm going to click edit right here. This right here is an edit rule expression dialog box. We're going to see this come up a few other times, but just to keep things simple, I'm just going to type in a constant and say 200 for 200 CFS and then click OK. So this is the flow through the gate. It's fixed at 200 CFS. That's the rule, as you can see it listed right up here in line 7. And also notice that the set operational parameters type of code is brown. So I'm going to select that again. Now you notice there's a gate flow fixed and a gate flow desired. The gate flow fixed does not affect the gate opening height. The flow will be released regardless of the gate height, 200 CFS that I entered. This flow will be used for each time step until it's changed. The next parameter down here is gate flow desired. Oops, so I went ahead and actually changed this fixed because it was highlighted. Let me switch it back to fixed. Click the next row down, which gives me, a fresh new line to work with. Set operational parameters, still getting used to this. And then now I'm going to set gate flow desired. And I'm going to set this to 200 as well, just a constant value, and then OK. And I also need to select a gate group as before, which is gate group 1. This value of 200 for desired is not a specific value, it's a desired value. It's an approximate value based on the inexact and iterative process of balancing different water surface elevations at the same time within the HEC RAS model. If the user wishes to force a given gate flow, but also wishes to know the approximate gate settings that would result from that flow, then this can be done by setting both the fixed flow and the desired flow to the same value, which we have here at 200 CFS. So as I understand it, the gate flow desired really will adjust the gate height, whereas the fixed gate flow fix will not. All right, let's go ahead and look at a few more set operational parameters here. We have gate flow max, gate flow min. That's setting the maximum and minimum. If it isn't already set, we can do so in the code. There's gate opening. That's the height of the gate opening rate, gate closing rate. Okay, so there's a number of gate coefficients right here. Some of these things I have a hard time imagining would even change during a simulation, but here they are. And then further up, we have weir parameters because that lateral structure has a weir on top, a spillway. And then we have structure wide parameters. So this would be like the flow through all of the structure, which is all the weirs, all the gates, and so on. There's fixed, there's desired, there's additional. This allows the user to increment the flow from the previous time step. I'm going to go ahead and delete this row 9 right here. And to do so, I just click the delete button over here. Okay, it's gone. And as you can tell, there are a number of different parameters that we didn't get to. And I did want to just let you know that in the user's manual, I'll link to this page in the description of the video if you want to check this out. But like I said, there's a lot of screenshots and descriptions. Here's the section right here for set operational parameters for hydraulic structures, which I'm pretty sure means gates. And if you scroll down a little bit, it gives you the definitions of them all listed out here: weir, structure, and so on. Below that, there's set operational parameters for the pump station. So here are the different pump parameters defined. Just sort of at your leisure, you can go ahead and read what those definitions are. All right, let's go ahead and carry on. Next, we have the next button is branch if/else. So if I click on that, the first thing we need to select is the branching line type. If it's just an if then, if and or then, else if then, else if and or then, else and if. I think that pretty much covers everything you need to do. Obviously, you can probably do the same thing multiple ways here. It starts me off here with just the generic if then, which you can see here on line 9. And based on the radio button I select over here, it will require different input over to the right to actually set the values. If I start with an if, I should also end with an end if, just best practices. So let's go ahead and do an example of that. What I'm going to do is say if the flow rate at River Station 5000, and then OK, is greater than, and then I'll set this expression to just a constant. I'll say 500 CFS, OK. So this is my if statement. Then I'm going to come down here, branch if else. Before I forget, I'm going to add an end if, OK? And then inside the if statement, but above the end if, I'm going to add my expression, which will be to increase the gate opening. So what I'm going to do here is set an operational parameter now. And this is for the gate of the lateral structure because that's the rules that we're editing here. I'm going to come down here to gate opening. Here's gate opening. Here's the gate group 1. And then what I want to do here for the expression editor is set that equal to gate opening and then plus 0.1 and then OK. All right, so what this says is if the flow rate at River Station 5000 is greater than 500 CFS, I presume, then increase the gate 1 group by 0.1, and I believe that's feet. So see how that kind of works, where we got an if-then statement and then a operational parameter operation inside of that. Now, if I wanted to go ahead and just copy those 3 rows, I held down the Shift key to select all 3. I could go copy, go down to line 12 here, paste, and just make a quick modification. So if it's, say, less than, and then change the expression, the constant value to, say, 300 CFS, then I may want to, say, decrease by setting this constant to a negative 0.1. Okay? So that's a similar operation, but in the opposite direction. I can also go minimize. I can click this plus or minus to collapse or expand the if statements. That's not uncommon for IDEs. And then one other thing I could do is I could combine these two if else and if statements by using the else if. So I'm going to delete this end if line. I'm going to delete this if statement. And then right here, I'm going to click on branch if else. And then what I want is an else if then, this one right here. Okay, perfect. So now this is where I would specify that variable once again. Okay, and that's going to be less than, and then this is going to be 300. So this is just the same thing that we saw earlier, except one fewer line code, a little bit more compact. All right, the next button is math. So if I click math, it brings up a little math editor down here. As before, I can update an existing variable. We have more variables to work with, or we can create a brand new variable, type the variable in, and then create an expression over here, which will result in the value that we assign to that existing variable or new variable. I'm going to go ahead and make a couple new variables. First one is going to be at VSA total, and this is going to be the volume of the two storage areas. I know it's very simple. There's probably other ways to do it, but just wanted to give an example of something. So volume SA1, okay. And then expression number 2, this is going to be volume SA2. All right. So that is my math expression to create a new variable. Let's make one more example. I'll click math, another new variable. This is going to be VSA average. And then what I'm going to do now is get the average volume of these two storage areas. I'm going to click on edit. Here is the variable. So volume storage area 1, 0.5, and OK. And then I will add that to 50% of the volume of storage area 2 and click OK. And the sum of the averages is the same as the average of the sum. So we're good there. Okay, that was an example of math, so maybe I should add a comment. We'll call this math button example. And then up here, I can add a comment for logic operator example. Okay, looking good. One more to go here. This is going to be our table example, so I'll just add the comment now. Table example. In this situation, we're going to provide HEC RAS a table lookup and then a variable to use as an index into that table, which will be interpolated and return a value. So let's click on the table button. As before, we have our options for existing variable and new variable. I'm going to select new variable, and then I'm going to call this pump flow. We have the option for one-dimensional table or two-dimensional table. Being the very first example, let's keep it simple and just go with a one-dimensional table so we kind of understand how this works first. The argument name, I'm going to call this head because the flow rate through a pump is based on a pump curve and the head, and what we want to return here is the flow. There's probably another way to do this in HEC RAS, but this is just my example. Now, what we want to do here is interpolate. Yeah, we want to use interpolate. There's a few other options, but click on enter/edit table data. Now, what we have here for the columns is the head. This is going to be in feet, and then the pump flow, the flow rate, that's going to be in CFS. Let me just go ahead and grab that data here from my spreadsheet and copy Control C, and then I'm going to come over here and Control V to paste. So there's the data. And what I'm going to do is I'm going to provide HEC RAS, or this particular operation, the head that the increased head that the pump needs to lift the water, and then it's going to return the value here based on interpolation. So as an example, if I gave it the number, say 35 feet per head, it's probably going to give me the flow rate of 100 CFS. If I gave it a value of 5, it's going to be probably like 220, something like that. That's what I'm going for. So let's click OK. The last thing we need to do here is provide an expression, and this is going to be the head. This is the independent variable used for the lookup and the interpolation. So I'll click Edit. And right now, I don't have a variable to represent the head at the pump station. So let's go ahead and do that first. I'm going to click OK. We're going to come back to this rule. What I want to do first is get the simulation value and also new variable. So let me think about this. Let me do this. Okay, so push that table lookup one row down. That's fine. What I'm going to do is create a new variable. It's going to be called water surface elevation at river station 5000. And then over here, I'm going to scroll up. I'm going to click on cross section and then water surface elevation and 5000. That's exactly what I want. I already had the flow rate from river station 5000, but not the water surface elevation. Now I got it. It's going to use the current time step. So I'm done with this row 19. Next, I need to calculate the pump head, which is actually going to be used in the table lookup. That'll be my index value. So I'm going to click on row 20, then click on math. It pushes row 20 down to row 21. So now I have a new value here. It's going to be a new variable. I'm going to call this pump head. And what I'm going to do for the expression editor is say the maximum elevation is 55, not 500, 55. Click OK. And then subtract that from the water surface elevation at river station 5,000, which I just defined, and it is water surface elevation at river station 5,000. OK. So that's all we need to do. Oh, I need to also go back to the table here. Table. Oops. Sorry, I just entered a new table. Let me delete that. Here, I click it. Now for the expression, I want to add pump head as my variable. Okay, there it is, pump head, and then click OK. All right, as I understand it, that's how it's supposed to work. We'll do a number of examples with these rules because there's just so much to do here, so much to play around with. But say, for example, the water surface elevation was 40 feet at river station 5,000. That means 40 goes here. Pump head is 15. It would use 15 in this table right here. That would be a flow rate of about 187. Okay. And then 187 would then be assigned to this pump flow variable in the final row of our code. All right. Well, that was it for this exercise. We talked a lot about using user-defined rules to operate a lateral structure, or we could have done the same thing for a pump station. We set the gate parameters, the initial variables, then we clicked on this enter/edit rules operator and went through all of these buttons and gave examples to create variables, set operations, and then use math and tables to define the operations of the gate, not the lateral structure.